Good afternoon, everybody, and thanks for signing up to our webinar. I hope it's an interesting talk that we're going to deliver today. Insight into some of the things that we've done in the past and some of the problems. We've got a good attendance, 30 different companies, and we've got actually a global audience, which is really good for us because we're passing on something that we've learned in the UK. So let's get started with our tools for effective water pollution prevention. At the end of the talk, I've got a survey that I'd really like you to fill in because your feedback is really important. So obviously we can improve this in the future. So I'm looking forward to hearing some good or bad. So today, what we're going to hopefully look at and hopefully give you an insight into is why is water pollution prevention necessary? What is water pollution prevention? Why should you be concerned about water pollution prevention? And what can be achieved through water pollution prevention? I'm sure you know these subjects. I'm sure a lot of you, because I know the people attending and listening in, know quite a lot about this, but hopefully we'll give you a little, and hopefully it's something that you can use within your career paths. So a little bit of an introduction to me, because I think it's important to actually understand why I think I know so much about water pollution and why I'm so keen on it and why I'm interested. So I'll give a little bit of a history. So my background actually is as a maintenance craftsman for Ford Motor Company. I actually worked there for 24 years, but was involved in all sorts of maintenance, and the reaction to spills was one of the sort of areas I got involved with. And this is a key area for me because what it actually meant was that's one product. What used to happen at Ford's, what happens at hundreds of sites is a significant incident takes place. We're talking now not just a spillage, we're talking a major spillage, a tanker spillage, a hose spillage, hydraulic loss, or a fire. Everybody goes into a panic mode, tries to block drains, tries to clear it up. And what I noticed was a massive amount of waste. So back in the early 90s, I invented a product which was EnviroValve, which is a bladder system, and this blocked drains significantly. What I was looking for was something that actually instantly where I wanted it to be and allowed me to collect it. What I had seen as well is lots and lots of people still were using penstock valves. They still use them today, and they leaked. And I couldn't quite work out why we have a system to react, why you couldn't just control it. So I invented a product at the time. I got a lot of sort of rejection to my ideas, but now they're quite common. So that EnviroValve was my product in 1998 that I invented, and that's what took me on a little bit of a journey really, where I realized that there was a huge opportunity to actually pollution containment system in place. There is no reason why anything that leaks out of a site, whether it be fire, whether it be a spillage, actually gets into the water supplies. You can control it. So that was the start of the original product I made. I also developed a system around the EnviroValve, which was inflatable bladder, which is still used today. I think the Environment Agency still buy a copy of that product, and they supply the fire and rescue service. So the fire brigade throughout the UK will use this. I call it a bag on a stick. It's a portable device to a site. There's no confined space entry. Just simply block a drain with this portable device, and it's still quite popular today. We probably sell 10 to 12 of them a year and install them into sites, but they're very low key, low tech piece of equipment. I've won awards. So the Fuel Association Award for my toggle block system. This was in 2010. These was really the sort of change from using stopper systems, bladders, let's say, mechanical valves, which I introduced sort of about 2007 was your first introduction. And then in Syria 736, which I was appointed to support from the EA, actually asked me to get involved. I think mainly because of the background of inventing valves that stop pollution. And that was part of me. In 2012, I was invited to sit on that panel to cover the writing of Syria 736 and act as one of the launch speakers. So these are some of the companies that you'll have all heard of. These are some of the we've worked with, very proactive businesses in water pollution. We've worked on all sorts of projects where we've actually helped them from designing of brand new factories. We've cut down and changed the drainage design using the tools that I'm going to talk about in a minute to allow them to actually have an understanding of what risks they run, where the pollution risk is and how to stop it and control it. So hopefully we eliminate pollution. Some of the ones here like Kellogg's, we've recently worked on a project with the cost of a bun design by using tertiary design. Marks and Spencer's, you'd be surprised, just a storage depot where the Environment Agency insisted that they monitored their discharges, and we actually put toggle block containment valves in with the monitoring equipment to control the surface water runoff. So a chronology of where we are today with water pollution. and what the key drivers are for all of us, any of us designing sites and any of us operating sites. So originally we had a guidance which was really focused really on the coma sites, but this was about mainly about bunding and the control of. Buncefield, 2005. This is your sort of big game changer. This is when an incident happened that was significant enough to make the regulator, the Environment Agency, suddenly stand up and think, we've got something wrong here. Businesses aren't in control of what might happen in the event of a disaster, or just basically quite large spills. The guidance of Syria 736, we started writing it. So there's a big gap between 2005 and the Buncefield disaster, before 2012, which is when we sat as a committee, and then 2014 in the July is when we launched it at the Barbican Centre to actually get this guidance out there. And another driver, sentencing guidelines 2014. This significantly changed how businesses were treated when there's a pollution incident. Previous to that, let's face it, £1,000, you could pay it with your credit card. It had to change because there was no driver to make companies actually go, we need to clean up our act. And the fire prevention plans 2016, which are sort of the last ones, bearing in mind the Environment Agency had stopped really issuing guidance notes, so much as the PPGs have been retracted. This was because businesses were having fires, there wasn't any control, and what we're getting pollution, disaster from fires, and nobody seemed to be following any sort of. The beauty of this guidance is it tells the reader, and this is for guidance for regulated sites and waste sites, to read Syria 736. I think one of the key points that I'm going to talk about today is I don't think people have been reading the guidance correctly or understood what it actually means. Obviously, because I sat on the panel, I was there at the start. Hopefully I can put across some sort of energy to it and why we actually wrote a guidance the way we did. So let's just go backtrack a little bit to the Syria 164. What you've got here is it's primarily for the coma industry. So it's people building coma sites. So it's looking at those secondary bunds, the primary bunds, and looking how you control those and how they're built. So it's focusing on bunds. It's not really focusing much on else. Certain words, well, in that guidance is fit a penstock valve to your drainage system. That's how you isolate your drains. And to be honest, I'm working on a project this week where the consultant is totally referring to the word penstock valves for the drainage system. We know they leak. They're no longer in the new guidance anymore. The word isn't there, but still that term has stuck. And it's actually putting designs incorrect. It's not helping. It's actually making things quite negative because people are still referring to a guidance which was superseded in 2012 by Syria 736. And as I say, it's mainly for the construction industry. So it wasn't really being read by customers. It looked at by the people actually building the site. And I've just shown you here as an image come across here. This is showing a penstock valve. This is a recent job that we worked on. This is very similar, nice little actuator, penstock sluice gate valve. This valve here actually is in good condition, nothing wrong with it, but it's losing 2,500 litres an hour. Obviously the green is the dye that we're doing a test with, but that actually is of no point whatsoever. It doesn't stop a pollution incident. There's cause it to actually make it seal. This is what we're losing. So this is significant because there's a lot of sites that have used Syria 164. They've followed the old guidance and they've got equipment that isn't fit for purpose and never ever probably was. So Buncefield, this is your driver. So Buncefield happens as a significant event. It's the biggest explosion since World War II in Europe. So that's pretty scary stuff. Ash cloud. So we've got an ash cloud that's forming. You can see in the image. This has meant that cobras had to sit. The interesting thing is this design that if there was a fire, it would be a controlled burn. So they weren't really going to chuck lots of stuff on it. They'd have it as a controlled burn. But because the cobra had to sit, because we've got a problem with this ash cloud moving over to France and causing quite a significant impact, it was decided to tackle the fire. And the significant part of this is it's not the stock that really causes the pollution. It's actually the firefighting materials that's caused the water pollution. Everybody knows about Buncefield. They know about the ash cloud, and that's the bit that construction. But the legacy of Buncefield was the damage to the water supply, drinking water supplies. And also it raised the bar to say, hang on, guys, if we've got a coma site top tier that doesn't actually know what a disaster looks like, how do we expect any other business to actually have a plan? So Sirius 736 comes in, and that's the thing that we've been sat there and I've been brought into because of my background. It's got to be, these are the things that are coming out of the initial meeting. Document that's universally applicable to every site, not coma sites, all businesses, even a one-man band owning a garage. We're saying that they should understand what happens in my garage if I have a fire and I've got a load of barrels of oil, cutting oil. What's the impact I could have on the environment? So they can actually pick up a guidance, because this guidance is free. You can download it free. So there's no reason why you can't have it. Previous Syria guides are sort of £300 to £500. They're quite expensive guidance. This was taxpayer, supported by the Environment Agency. People like myself give our time free of charge. So hopefully you get a good guidance that gives you a good bit of knowledge. So it's to educate customers, really, rather than just people who are building sites. What I want is a customer to ask me the question, I need to fit a containment system to my site. I need to fit a containment valve. I don't see the word penstock anywhere in the guidance. It says pollution containment device. Can you then guide me to a pollution containment device? That's a significant day. Understanding the risk, obviously, what are the risks? The guidance covers all these factors that we're going to talk to you about in a minute. And updating technology. In other words, we've took out the words penstock. We've took out referrals to very specific items so that people can actually move their designs. The design has to do one thing: don't pollute. Penstock valves, a bit of a bugbear for me, is because these are what people install and keep installing. They're not really fit for purpose. They were never designed for flow control and some isolation. You've got to have the right product. You've got to think that when you have a fire, could be part of a power cut. So these devices must work when there is no power. So they need to be off grid. You can't have them connected into the main compressor line and running off an air line or running off mains power if the first thing that you've lost is power and you can't control the valves. They're normally out in the sort of middle of nowhere as well at the end of site. So it's very important that there's some sort of off-grid controls to them. They've got to be operable, as I said there. So they've got to link. So you need systems that are designed specifically for that. Maintenance issues. As you can see by this valve here, it's quite an easy one because it's outside, but these things are quite heavy. We quite often go to services, you saw in the original picture, quite big valves down manholes that they've built the biscuit on top. They're non-serviceable because we can't actually get them out once they're put in. Very little thought is put into the actual what this valve is going to do. It goes up, it goes down. Nobody bothers to actually check whether it actually seals the flow, which is absolutely essential. They've got auto monitoring, because to connect them up, they're quite slow to monitor. They don't react very quickly. They're not really the right product. They never were the right product. They're a flow control device with fantastic uses in the water industry and where you've got considerable flows. What we have to look at here is when you're looking at pollution containment, there is no pressure. The flow is just a nice gentle trickle potentially from the site just running into the drains. So you can see some of these pictures now that I've just put in here. These are typical examples of what we see to sites that are fitted systems. No thought. These valves have gone in, great idea, but no ability to actually get in there to maintain them. This one is actually a good one because this is to do with a site that I dealt with, which is actually one of the case studies in the Syria guidance on page 162, if you want to read it. This is where a penstock valve was closed as part of a tertiary system, and it leached cyanide into the River Anker and caused a major fish kill. I think it was 33,000 fish in total. Significant impact to the business. And that is because just wrong products. And these are typical where you've got manually operated valves. In the event of a fire, can you actually operate a manually operated valve when you've just evacuated all your site? Have you got the right people there? And do you know it's actually worked? Another typical example where somebody's put a penstock valve in and then decided to concrete around it. So it's a non-serviceable item. These bits of kit, significant changes within the guidance where we're asking people to service these systems and show they're serviced and show they're working. So a really big driver then to the technology that which I'm going to come on to now next is the sensing guidelines. Hugely important if you're not involved or you haven't really understood this part of it, but we've created a punishment, we've created a deterrent, and the removal of any financial gain. So in other words, if your business is running at a risk where pollution is insignificant, we don't worry about that. And there are a lot that do that, and there are a lot that don't. The fines are based on your total group turnover. So you might be a small part of a large company. Will be based on your total group. So if you're owned by a big international investment company or your Thames Water, your fine is related to your total group turnover, not profit, turnover. That's the step change into a lot of businesses suddenly realizing that the management of water and what happens when a disaster takes place needs to have some significant investment. It needs good drainage design. It needs good containment design. Thames Water, obviously, you see there, £20 million fine. I think you'll also find that Tesco pounds in 2017, I believe. That was for quite a minor oil spill, really. But again, it's showing the significance that if you're a company of that size, you shouldn't be having these pollution incidents. You should be employing the best technology and the best systems to prevent them happening. So now I'm coming on to now sort of our products and products that I think are significant. Now, something I call it spill mapping. And this is actually, if you read the Syria guidance, you'll see it's on case study on page 130. And this actually is a replica of that site to sort of create a sort of a much simpler image that I'm going to show you. What we found with Buncefield, whilst I'm on the committee, was Buncefield had no evidence or idea what a pollution incident would look like. Now, why this is really important is because what had been happening was people were placing containment valves in, building tertiary containment that they thought off drawing. So there's some effort going into it. But if you're actually the owner of a site, you are probably not skills to understand that drawing. So what I could see was that sites were installing and investing in equipment with no actual evidence that what they were investing in actually worked. So where you go now into the Syria guys, understanding the risk, you'll see there's a section 433. Now this is about looking at how rainwater impacts a pollution event. So as I'm doing the guidance, we're looking at this because there is no sort of benchmark, and we realize that the guidance is allowing us to set up a system so we can actually empower decision makers by using what's set out in the guidance to say a 1 in 10 year rainstorm event, loss of whatever stock we're considering we're going to lose, and whatever your firefighting response is going to be, gives you a volume. And by that volume, through micro drainage or true flow, whichever software you're using, you can actually then just carry out your flood modeling software, which the Environment Agency helped develop and produce, which is now so significant in the design of new builds, blocking the drain. To assume is that somebody has selected the right valve and not a valve that leaks. So it's really important to select the correct valves. But once you've done that, you're creating a model and you can see the ground, above ground flow paths. You can actually then see whether the system you've got works, and you can see what you need to design. This reduces costs significantly in a major way. And we've done sites where originally they were going to build bunds around facilities. Actually, by doing it in the tertiary, you were able to control it even better. And what you've got is, I'm sure that if you present this in front of the Environment Agency, which we have done with several companies, which I can't really mention their names, but we have done it. We've evidenced this to the agent from the Environment Agency to show them what we're going to design. And this helps deliver your permits. It helps deliver your scheme, because the Environment Agency, the officer, if they can see what you've actually designed actually works, it makes things a lot easier. And it actually costs significantly. It's satisfying the authorities. So what I've got here is, this is an image that I'm going to run now. This is what I call an incorrectly designed system. So let's just watch it run. What you've got is where my arrow is. That's where the valve is placed. That's where the contractor actually fitted the valve at this site. And as you can see, it's filling this area here is the staff car park. We're coming out of here and we're flowing into the river. This is the river below, and we're actually having a pollution event. This is the attenuation design. It's actually the loading bay, which now what's happened is, and it's quite a sort of simple sort of image, but what we've got here is system was designed, put into place, but somebody made us an error of placing the valve in the wrong place. Looked okay, and it's quite common. We go to loads of sites where the valves have been bought. Nobody knows whether they actually work. Nobody's ever had a significant event where they had to shut the valve. They're just assuming they work, and I can quite quickly see that some of the sites we work with don't. So what you've got here is you've got a huge, planned out. This obviously animation wasn't done, and somebody's put a valve in. That's where it's got to go. I have to assume that valve does seal. I have my doubts about this one personally, but what you end up with is a system that doesn't work. So when we go to this one here, I haven't changed anything. So we haven't changed any of the volumes of water, the volumes of the containment. Nothing's been changed at all. So all we're doing here really is using the design that was done. So we're using as you could just show. So this is a roadway. This is the loading bay. So this is where you're dropping down to. So this is our natural area we want to sort of flood and push the pollutant into. This is how it's been designed. And we've moved the valve back. We've moved the valve to another, actually, It's another manhole that had to be created. So this is why it was originally wrong. But now as we've run the model, it's the same event. It's the same volumes of water. It's the same thing that's happening. But now we've got control of it. This is the significance of being able to see what the design is. Key people involved in a project can actually see that what you're going to build first. What I personally see is lots of sites. EA might walk onto site and say, you need a containment valve. Right. That's what we're going to do. We're going to put a containment valve in. No thought into actually, will that containment valve do what I expect it to do? And this is referring back to Syria using the guidance, using section 433, which gives you the volume of rainwater, which is your worst case scenario, looking at what your materials are and looking where you're storing materials. You can volume. Once you've modeled the volume, you can design your containment to actually work. So things like Buncefield, wouldn't have happened. If you'd have modeled Buncefield, you would have seen the errors, you would have seen the faults. Only one thing that they needed to do was they needed to understand, which sites do, is a penstock valve is probably got a leak rate and it's not the right product. Valves that contain drainage need to be a drop seal design. What I've got here now is I'm going to do a little bit about the toggle block. This is products. So I've moved products along from drain block, from all sorts of products that I've made over the years, and EnviroValve. This is where we're at now. So it's purposely designed for pollution containment. It's not designed for flow control. It's designed for one thing. It's designed, if you have an incident, I want to close a drain instantly. I want to close it off quickly. I want to close it in about 5 seconds. So what we have here is a valve that's simple. It's got its own power supply, so it's running off a battery. It's got its own pneumatics. It's operable, so you can connect it into your fire alarms, anything you want to connect in. M2M control it, so you've got control of that. Self-contained, so you're not putting in mains power to this. You're not putting any air supplies or anything off-site. This is totally one piece of kit that takes itself, and it's adaptable. So this actually picture you see here, and I'm going to run it hopefully as a video in a second. This is actually fitted into an existing manhole. We've done the bench work. It's very similar if you were fitting a hydro brake. You're creating a flat face, and the valve just bolts onto it. Ideally, you'd have a catch pit, so you'd have a bit of a drop, but we quite often have to to do it. Significant difference if you notice from the drawing, this is a small piece of kit, and what you've got is it's all modular, so it's very light. So it's plates, it's guards, they come on, they come off, they bolt off. If this was a penstock valve, we'd be putting it in with a crane. This is no more than about 40 kilograms is the heaviest part, and what you're looking at there is a 500 mil valve. So it's quite a significantly big valve doing exactly what it needs to do, but it can be put in quite easily. It's quite lightweight. Issues, you haven't got the safety issues that you normally have with a big penstock valve where you need the biscuit off. We say these are future proof. They're shown in the guidance, so if you do read the Syria guidance, you'll see it on page 34 actually bolted to a penstock valve which didn't work. It's another sort of point of why you've got to get the right valve selection, but this is what it's doing. It's future proof. Hopefully this animation will run. So this is animation now running. That's how a valve works. What it's doing, this is the flow is pushing against the flap, so it's what we call on-seating. That flap has just dropped into the flow. We'll open it now because what we're doing is just a test. That's all it is. The water is pushing that flap shut. We have a little bore hole in the center of it. Well, that will release any lock pressure to allow a flow through, because what we're not looking for really is to suddenly release the whole flow. The significance about this is we have got a system here that is designed for pollution containment. So when you've operated this system, be informed, it communicates to you. This one now will just reset, so it's just resetting itself afterwards. That's it's back in action, ready to be used again. That is a significant difference between what's already on the market. Is it's got to be quick. Whatever you're doing, it could be a spillage, so you want a valve. We do a lot of sites that will say we close our valves whilst we've got production, so they could be closed for a whole day. I think this is a really bad advice, because what you're doing is a drain needs to flow to clean itself. Allowing it to build up detritus, sediment, you're actually causing it not to work. These valves have been designed so you link them into your system, however it is, panic button or whatever you want to do, and you literally are able to shut a valve in 5 seconds. So on an event of an incident, bang, valve shuts. There's no need to hold drainage, which is not how the drainage engineers designed it in the first place. Some images. These are just some installations of where we've done typical sites. You can see here, this is it's actually a chocolate factory, and you can see the It's only small. You see the little unit on the top there. That's actually a remote button that we connect into then to a fire alarm. So it's not, there's no cables. What that does is that connects into the fire alarm. The fire alarm goes off. It connects a little M2M message, basically like a mobile phone really, and it communicates with the valve. You can cable in as well if you really want to, but really we're trying to make it so it's simple. This is basically a complete contained system. There's no need to add anything. Solar power, as you see, battery, off grid. You can put mains into it if you really want to. Now, recently was for an airport where we're monitoring pH. Significant that what they're looking for is to their pH levels, and they want to hold their attenuation ponds when the pH levels were high or low. So it would seem natural that if you've got a pH monitoring equipment, wouldn't you really want to connect it into a valve so that a valve can actually stop the flow instantly? And what we've done here is very simply is pH system sits on the pond. It's connected into our valve just next to it. When the pH goes off, it drops the valves, which stop the attenuation pond. It alerts staff by an M2M message and network message because it's connected into their network. It's also linked into their control tower so they can operate the valves from the control tower. But what it means is that instead of going, we've got a monitoring issue or a discharge consent issue, oh, well, we let it go for the last 2 days, we haven't just spotted it. What this is doing is it's connected to a dead stop. So as soon as this goes into alarm, it's activating a valve to give you a communication. I'm in alert. I don't want to come and do something about it. It creates, it really stops this sort of, something goes into alarm and somebody then has to respond to the alarm and do something about it. This is going alarm stopped. Similar with an oil separator alarm, you can see there. It's very simple. Oil separator alarm, take it at a fuel station. If that hits a high alarm, it just shuts the discharge consent, stops the pipe straight away, dead. There's nothing getting out of there. Then the idea is it's calling you in to react. Really, it's quite common that we see sites that have got monitoring equipment and spent a huge amount of money on monitoring equipment, but don't actually have any controls to actually do anything about it. So really, that's it now. So I've come to the end. I've got a good guide that you can download. I'm open to any questions. Please do. I know that sometimes people like to send emails, so there's my email. Please do give us a call or send me a private email. We have got a service. It really is important because most of the technology that I've developed is really from working with customers, working with engineers, drainage engineers. I've worked with a whole array and looking at what's driving them and what they feel is problems they've got, because there are solutions. Water pollution is quite simple. I mean, we're bringing in new products all the time. Plastics is a big issue at the moment, and we've got solutions for that now. And we're working with different companies all around the world. So really what it is your feedback is helpful if you want to get involved and be asking us questions. And certainly I don't mind being challenged on any of the products I've just talked about today and the spill mapping and how it works. But I look forward to hearing from anyone that's been listening today, and please pass on this talk so we can perhaps enlighten a few more people. Okay, thank you. Bye.